Network switches, VLANs, and MAC attacks simplified. Let's start with a switch which primarily operates at layer 2 of the OSI model but may be equipped to operate at layer 3 or higher. Now switches can either be managed aka clever or unmanaged aka dumb. In this video we shall focus on managed switches. But firstly, a key technical note: all switches, managed or unmanaged, operate under 4 primary functions, being learning, forwarding, dropping, flooding. To help illustrate these 4 primary functions, let's use an analogy of plumbing pipes and water. You see, picture the legend key as the pipes being the Ethernet cable, the piping system being the local area network LAN, the water being the Ethernet frame, and the water flow being the traffic or traffic flow of Ethernet frames. This water flow is known as the learning mode, which is where the switch becomes aware of its local network, the same way the piping system becomes aware of the water pressure and flow. So think of the water drop as the Ethernet frame, which goes through an Ethernet port, which exists on the switch. Now the switch receives each inbound Ethernet frame and evaluates this against an internal table known as the Content Addressable Memory CAM table. This table stores the MAC address and its associated port number, and also VLAN information, which will be explained later in the video. So, to understand this concept, let's build this illustration out further. When the switch receives the Ethernet frame, it firstly takes out the source MAC address and checks this against the CAM table. Note, if the Ethernet frame source MAC address is not in the CAM table, it is added, along with its associated port number. Key technical note: the physical RJ45 jack is the port number rather than the TCP protocol port. Don't get confused between the two. So after the switch checks the source MAC address, it then checks the destination MAC address, again against the CAM table. And this is where it gets interesting. If the destination MAC address is present in the CAM table, then the exit port in the CAM table is compared to the port that the current Ethernet frame was received on. If the port numbers are different, aka 4 and 8, then the frame is forwarded out the exit port. And key technical keynote: this process is known as the forwarding primary function. But what if the port numbers are the same? Then the Ethernet frame is dropped since it's already present on the correct network segment, aka the frame is routed to the correct RJ45 Ethernet jack. And this is the dropping primary function. So now you might be wondering about the flooding primary function. Well, in the event that the destination MAC address is not present in the CAM table, then it is flooded or sent out to all Ethernet ports. This is known as flooding, aka the water going through every single pipe till somebody says, "This is for me." Okay, so now we understand some basic fundamental concepts. Let's focus on the CAM table, specifically VLAN, Virtual Local Area Network, which is an additional option on managed, aka smart switches. Put simply, a hardware imposed form of network segmentation created by the switch. A very key technical CISSP exam tip: do not confuse VLANs with subnets, although VLANs could be treated like such, but are not the same. You see, VLANs are created by physical switches at layer 2, whereas subnets are created at layer 3, the IP Internet Protocol layer, and are more masks, aka virtual, rather than having to rely on a physical element such as a switch. A good way to remember is a subnet is used to logically divide a network into smaller parts using a mask, whereas a VLAN is used to segment, aka split, a network into separate networks, logically, aka virtually, without altering its physical topology, but relying on the switcher's ports. Now let's deep dive into VLANs. VLANs are possible on managed switches, which offer this additional configuration option. This is important in relation to VLANs. You see, an unmanaged, aka dumb, switch may not understand the layer 2 protocol around VLANs. and VLAN encapsulation, which leads to various attacks such as VLAN hopping, which will be explained shortly. Going back to the standard Ethernet frame, specifically the headers. When using VLAN encapsulation, the Ethernet header is modified with a VLAN tag, which is structured like this, in between the source and the type headers. Now, a network admin can configure the switches ports to be part of various different VLANs, such as VLAN 1, VLAN 3, and VLAN 5, etc., etc. In hindsight, VLAN 1 was a bad example, being a default, but let's just go with it. Let's say VLAN 1 was for everyone, and VLAN 3 was for HR, and VLAN 5 was for finance, meaning those ports on those assigned VLANs or for those specific devices or people assigned in those departments. So, a question for you wonderful viewers. What happens when there are more devices than ports on a switch? E.g., we wanted to expand HR, but we don't have enough ports on the first switch. Please feel free to pause this video now whilst you think this through, and I will explain the answer in a moment. Welcome back. The answer is known as trunking, or trunk ports. The trunk port allows a link to be created between one or more switches which can talk to each other directly, direct traffic between the hosts, and even stretch VLAN definitions across multiple physical switches. The very last port on the switch is usually the dedicated trunk port, which can be used to cross over two switches on exactly the same trunk port on both switches. It is also worth noting that VLANs can be replicated across both switches, or can be expanded across different ports, and even new VLANs can be created, so further VLANs can occur not just on one, but across two or three switches. Again, VLANs are accomplished using special signaling defined in the IEEE standard 802.1q, known as VLAN tags. Please remember this important standard and the concept of VLAN tagging, as later in the video we will look at some of the attacks that can be done to exploit this process. Now, whilst on the topic of switches, I think it's important to understand another technical feature known as port mirroring, aka the span port, switch port analyzer. Another feature found on many managed switches. The span port will duplicate traffic from one or more ports, known as mirror ports, and will send the mirrored data out through another designated port, known as the analysis port. Port mirroring, sometimes known as port spanning, is often used for network traffic analysis, packet capture, evidence collection, and intrusion detection. The dedicated out analysis port on the switch usually connects to a server or a device of some sort, which is used for network traffic analysis that is coming out of the duplicated traffic mirrored from the switch on the designated ports that the admin has configured to be monitored through port mirroring. Bonus CISSP exam tip. Another element of some VLAN deployments is port isolation or private ports, which basically means some VLANs are configured to use a dedicated or received uplink port, aka exit port. And the bonus tips keep appearing. What about the cloud and virtual environments, you might wonder? Well, distributed virtual switches, aka centralized switches, are becoming more common than standalone virtual switches because they help reduce the chances of introducing configuration errors. As part of Infrastructure as Code Architecture Design IAC. Stay tuned and subscribed for a future video on IAC. And in this last section, let's use some applied knowledge to look at some cybersecurity attacks on all the concepts we have explained throughout this video, starting with the VLANs. Remember the VLAN encapsulation header inside the Ethernet frame? Well, early switchers were not prepared for attackers to think outside the Ethernet frame box by adding an extra tag known as double tagging, aka VLAN double tagging, a bit like the IP ping of death, where attackers circumvent the original protocol, which was never designed to be exploited in such a way, especially so many years into the technology future. A common theme of cybersecurity, legacy systems not keeping pace with technology advances. So the double VLAN tagging, aka extra tag, would mean that an attacker could hop from one VLAN to another because old school switchers, after reading the first VLAN encapsulation tag, would not expect the next frame to be another VLAN encapsulation tab. so essentially have no security, therefore allowing the VLAN hopping to occur. In this example, first going to VLAN 3, but then hopping onto VLAN 5. Moving away from VLANs and back to Ethernet layer 2, and attacks on the Ethernet frame MAC addresses. Starting with a MAC flooding attack, which is an intentional abuse of a switcher's learning function to cause it to get stuck in flooding mode, by sending loads of randomized fake MAC source addresses, which will get added as new entries into the CAM table, eventually flooding it, crashing it, and reverting it back to a dumb old school switch, which actually acts as an even older hub by just sending Ethernet broadcast and frames everywhere, because this CAM table is an additional feature. And in another similar way is a MAC cloning attack, where no two devices can have the same MAC address in the same local Ethernet broadcast domain. However, when they do, problems occur. Again, it's not hard for attackers to circumvent and make a false MAC address, which is a clone of another device, which is a legitimate device. Therefore, an attacker can impersonate another device by just being or pretending to be its MAC address. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.